Okay, in this video we're going to look at sum and difference, multiple angle, double angle, half angle formulas. It's going to be really formula driven. So on your Google Drive, for your class Google Drive folder, feel free to go in, print off, or just have it up and available, your different formula sheets. One of the first examples that you're asked to do in your homework is to find the exact value of an expression, such as this one, cosine of pi over 4 plus pi over 3. If we were to add these two angles, we would get 7 pi over 12. Unfortunately, 7 pi over 12 is not marked off on your unit circle, so there's no x-coordinate that you can go grab and just put that equal to. Using your formula, and you'll look at the one for, it'll be in the sum and difference section of your formulas, and it'll be the one with cosine plus. Now, the expanded form of that will be cosine of pi over 4 times cosine pi over 3. And if you'll notice, the plus minus symbol is inverted on this expanded side of your formula. So you'll actually go minus and then follow it up with sine pi over 4 times sine of pi over 3. Now these values are on your unit circle, and we can grab those off of there. So let's go for the unit circle, and you'll want to keep your formula sheet and your unit circle handy. It's great if you memorize the unit circle. It'll help you in Cal 1, but for this class I don't make it mandatory, especially since we're all online. Anyway, cosine of pi over 4, you go to pi over 4 on your unit circle, grab the x-coordinate, go to the angle pi over 3, grab that x-coordinate, minus, go back to pi over 4, grab your y-coordinate, and then finally go back to angle pi over 3 and grab your y-coordinates. Remember, cosine is x-coordinate at each angle, and sine is y. And that's going to give us square root of 2 over 4 minus square root of 6 over 4. And it's not mandatory, but if you wanted to write that a little more compactly, square root of 2 minus square root of 6 over 4. Part B, you're asked to just find cosine of pi over 4 plus cosine of pi over 3. Now what this is an exercise in showing that the sum and difference formulas are not distributable. I'm not sure that's even a word, but you can't use the distributive property. Turns out, if you look at the problem we just finished, if you were to try to distribute cosine to pi over 4 plus cosine to pi over 3, you would get this expression that I've just written, but when we write the values down, cosine of pi over 4 plus cosine of pi over 3, we do not get the answer we got from the sum and difference formula. That's part B of your problem, is just an exercise on what not to expect. Now this can also be written a little more compactly. Square root of 2 plus 1. Now with adding, it's a common denominator. You don't multiply them. Let's do one with sine. And we'll also do one with degrees. Okay. So while you've got your formula sheet handy, in the sum and difference section, look up sine, and specifically the one with sine of u plus v. Now to expand sine, we have sine of the first angle times cosine of the second angle. You don't alternate sine, you don't alternate the sine and the expansion with sine, you just keep it the same. So that's plus, and then we have cosine of the first angle times sine of the second angle. Those expansions are different, so be careful. All right, hop back to your unit circle. We had the formula sheet to get the expansion done. Hop to your unit circle. Sine of 120 is square root of 3 over 2. Cosine of 45, that's the x-coordinate at 45, plus cosine of 120, go back to 120 degrees, find your x-coordinate, you should see a negative half, and then go back to the angle 45 degrees, your y-coordinate, square root of 2 over 2, so that's your sine value. Multiplying, we get square root of 6 over 4 minus, be careful here, square root of 2 over 4. And then if you wanted to get those together, square root of 6 minus square root of 2 all over 4. In this example, we're going to write this expansion as a single expression. Staying with your sum and difference formulas, concentrate on the expanded side and find one that has an expansion of cosine cosine minus sine sine. Backtrack that to the simpler side and you'll find that the sign has to be inverted. If there's a minus in the middle, let me highlight that. The ones that start out cos cos and end up sine sine are going to be cosine. The first angle is 110. The second angle is 20. But with a cosine expansion, you go opposite. Actually, let me keep this color coded. With cosine, whatever you're doing to the angles in parentheses, the expansion will have an opposite sign of that in the middle. So this one we're going to have, as a single expression, will be cosine of 130 degrees. Now 130 is not marked on your unit circle, but this one didn't ask us to find an exact value. They just wanted us to be able to go back to the more condensed side of the formulas. Let's try a second example. Let's look at sine of pi over 16 cosine of 3 pi over 16 minus cosine of pi over 16 sine of 3 pi over 16. Okay, now in your expanded side of the sum formulas, the one that starts sine cosine and finishes cosine sine is sine. Our first angle was pi over 16. Our second angle was 3 pi over 16. Now, be very careful. The sign in the middle in a sine expansion doesn't change. If it's a cosine expanded, you do change the sign. But if it's not, then you keep, if it's a sine expansion, then you keep the sign the same. Pi over 16 minus 3 pi over 16 is negative 2 pi over 16. So it's going to be sine of negative 2 pi over 16, which will reduce to, and since sine is an odd function, you can even go so far as pulling the negative out. And when you reduce, 2 over 16 reduces to 1/8. Because pi over 8 is not explicitly marked on your unit circle, we're not going to worry about giving the exact value. I just wanted to give you a couple of examples of expanding a sum difference formula and contracting or condensing. And so I hope I've done that. Hope it helps. Let's actually do one with a tangent. We haven't touched tangent yet. Now this one we're going to go all the way out until we get an actual answer. So let's go tangent of 25 degrees plus tangent of 110 degrees all over 1 minus tan 25 times tan 110. Okay. While you're looking in your sum and difference formulas, you're going to want to find, of course, the dead giveaway on this one is its tangent. That's not a problem. But what you really have to be careful for is we know that's an expanded tangent formula, but we've got to be sure we match up which one, whether we add the angles or subtract them based on what you see on top and bottom. Find an expanded tangent formula with a plus sign on top, a minus sign on bottom, and then when you backtrack it, you should find tangent, and you go by the one on top. So if a plus sign's on top, you're going to add these two angles. Well, what's 25 plus 110? Yep, tangent of 135 degrees. And from your unit circle, the tangent of 135 degrees, which if you look at the unit circle on your Google Drive folder that has tangent values included, I've got a -1. I've got those tangent values all the way around the perimeter of the circle, so you should see a -1 for a tangent value. Given cosine theta is equal to -12/13 and the angle is located in quadrant 2, that's an angle between pi over 2 and pi, we are asked to find sine of 2 theta, cosine of 2 theta, and finally tangent of 2 theta. In your double angle section, we're going to switch from sum and difference to double angles. You'll find that the expansion of sine 2 theta is 2 sine theta cosine theta. Now let's take the information given. Cosine is -12/13. I'm not going to worry about drawing it to scale. I'm just going to draw a triangle in quadrant 2. Cosine is adjacent, or the x direction, over the hypotenuse. 169 minus 144 is 25, and the square root of that is 5. If you need to jump over to the side and use Pythagorean theorem, that's just what I verbally did right then. Okay, back up to sine 2 theta. The sine is the y direction over the hypotenuse, or opposite over hypotenuse, however you want to think about it. That is 5/13. And that's from that diagram at the bottom left of the page. Cosine was given. Multiplying out, that is negative 120. 2 times 5 times negative 12 over 13 times 13 is 169. Cosine double angle, when you look at your formula sheet, you have 3 different options. They're all as good as the other. Pick whichever one you want to work with. It is totally fine. I'm just going to use the very top one, which is cosine squared theta minus sine squared theta. And just plug these numbers in. Cosine was negative 12/13. Squared minus sine from the diagram was 5/13 squared. So that's 144 over 169 minus 25 over 169. And that is 119 over 169. I'm going to box that one in. That one tried to hide. There is a formula for tangent double angle, but let's not forget, tangent is also known as sine over cosine. We've worked pretty hard on parts A and B, and we can use that hard work for this one. Okay, now what was our answer for sine 2 theta? Negative 120 over 169. And then the answer we just got for cosine 2 theta was 119 over 169. Okay, that's a complex fraction, so negative 120 over 169 times the bottom fraction flipped. Dividing by a fraction is the same as multiplying by the reciprocal. Cancel, wonderful cancellation. Negative 120 over 119. And you can use that for your tangent value. If you were to use the tangent 2 theta expansion, which is two tan theta over 1 minus tan squared theta, you would get this answer. So it would be a little more difficult to use the formula, but you absolutely can use it. I always recommend, if you know sine and cosine, just use those to get your tangent. Because you've already worked hard on A and B, you might as well make C a little as easy as possible. But that formula will give you the same answer. In this problem, we're asked to use a half-angle formula to find sine of 75 degrees, cosine of 75 degrees, and finally tangent of 75 degrees. If you weren't given any specific instructions, I would recommend actually solving this using a sum formula, specifically sine of 45 degrees plus 30 degrees. Then you would expand and solve that way. You can pull your values directly off of the unit circle. But since we're asked to use half angle, I wanted you to be aware of the little bit extra it takes to get through it. In fact, I always recommend sum and difference if possible. 75 is half of 150. So this is how we would get it started. Okay, find your half angle formulas, that little section on your formula sine of theta over 2. Now, if you'll notice, there's a plus minus in the formula, and I'll explain that in just a bit. But we have a long square root 1 minus cosine theta, which is going to be 150. It's very tricky. I'm going to make a note of that right here. Because 75 is half of 150. All right. As far as and let's see, let me finish that out real quick. All divided by 2. All of it under the radical as well. Okay. Now, as far as the plus minus goes, you look at the original angle. 75 degrees is in quad 1. Sine is positive in quad 1, so that tells us to take the positive root. The positive one. From your unit circle, and you don't have to write the plus sign out front, cosine of 150 is negative square root of 3 over 2. Negative square root of 3 over 2. It's the x-coordinate at 150 degrees. Now that gives us square root. Think of 1 as 2 over 2. So that's 2, the two negatives make a plus. 2 plus square root of 3 over 2 all over 2 which gives us square root 2 plus square root 3. These are real messy problems too. Those 2 in the denominators, if you get them together, it creates a 4. 2 times 2 is 4. And so we get square root 2 plus square root 3. Yeah, there's a radical underneath a radical, and then just a 2 down here. Very nasty stuff. You'll have to be very careful doing your homework. Same thing is true with cosine. The only difference, instead of having a minus sign under the radical, and we're going to look at this also, that 75 degrees, that's still quad 1. Everything's positive in quad 1. So we have square root. Instead of a minus sign, it's just a plus sign. That's the only difference. Okay, so that gives us square root 1 plus negative square root of 3 over 2 all over 2. Okay, and like we did above, treat 1 as a 2 over 2. So that's going to get us to radical 2 minus square root of 3 over 2 when you combine denominators over that same 2 that's in the original denominator. And like we did up top, that's going to be 2 minus square root of 3 under a radical. The couple of 2's as denominators are going to make the 4 again. And that's those 2's. equals just a radical on top, 2 minus square root of 3 over 2. Tangent of 75, like we did on the double angle problem, we can take our top two answers, sine 75 over cosine 75, and use them. And since we're doing a difficult problem anyway, let's try to alleviate some of the pain from this one. Okay, sine 75, that was the first answer up here in the top right. That was square root of 2 plus square root of 3 all over 2 divided by or times the reciprocal of the cosine answer, dividing by a fraction, which is that one. The only difference was it had a minus sign under the radical. Okay, good. These 2's will cancel. That gives us square root of 2 plus square root 3 divided by square root of 2 minus square root 3. You might try that answer in WebAssign. To be honest with you, it's a good answer, and it's just as good as if we were to rationalize. And I'm going to go ahead and rationalize it just in case you have to on your WebAssign. I'm really hoping you don't. Okay, so rationalizing, we're going to take the denominator, change the sign in the middle, and multiply both sides of the fraction by it. Change the sign in the middle of the denominator and multiply your fraction top and bottom by that value. Yeah, it's a headache. Let's try it out. Okay, now on top, let's see, I might do better to come down here with it. It's just going to be a headache either way. Yeah, I think I'm going to do that, so I'm going to erase that. Okay. On the top, when we FOIL that square root, FOIL underneath, that's 4 plus outside is 2 square root of 3, inside is 2 square root of 3, for a total of 4 square root of 3. That's the O and the I FOIL. Last times last, square root of 3 times square root of 3 is 3. And then on bottom, foiling, 2 times 2 is 4. Outside is plus 2 square root of 3. Inside is negative 2 square root of 3, so those cancel. Minus square root of 3 times square root of 3 is 3. All right. On the denominator, we really catch a nice break. 4 minus 3 is 1. Square root of 1 is 1. So we get a 1. Under the top radical is 7 plus 4 square root of 3. And then divided by 1, it's going to stay the same. Given sine theta equals 5/13 and our angle is located in quadrant 2 between 90 and 180, or pi over 2 and pi, the first thing we're asked on this last homework problem is what quadrant theta over 2 is in. Theta over 2 requires dividing everything by 2, and so that gives us pi over 4, which is 45 degrees, and 90, or pi over 2 radians. So that tells us that our half angle is going to be in quad 1. Quad 1. That's the first thing we're asked on this homework problem. Then we're asked to find the exact values of sine, cosine, and tangent of that half angle. Well, let's use the information given to sketch a diagram. Sine theta is 5/13, and it's originally in quad 2. Again, I'm not going to worry about drawing to scale. I just want a right triangle in quadrant 2. Sine is opposite over hypotenuse. This is like the diagram from a previous problem we did. If you use Pythagorean theorem, and keep in mind that your x is in a negative direction, that side will need to be recorded as a negative 12. Sine theta over 2, because theta over 2 is in quad 1, everything is positive. So that helps us on deciding positive or negative. We're just going to write positive for all of them. Alright, so sine of theta over 2, look at its formula. That's square root of 1 minus cosine theta all over 2. From your diagram, cosine is negative 12/13. 1 minus negative 12/13 all over 2. 1, think of it as 13 over 13. That way you'll have a common denominator. 13 minus negative 12, that's 25 over 13 if you get a common denominator. So that gives us square root of 25 over 26. Square root of 25 is 5. 26, we'll just leave it square root of 26. I did check on WebAssign previously to making this video, and you can leave that unrationalized, and it's okay. So you don't feel like you have to multiply top and bottom by square root of 26. You absolutely can if you want to, but WebAssign will take it unrationalized. Now the cosine half angle, we'll just put a plus sign in the middle instead. So that gives us radical 1 plus, back to the diagram, we still have negative 12/13 for cosine, all over 2. Again, think of 1 as 13 over 13. 13 minus 12, that's 1/13, all over 2, which gives us square root of 1 over 26, which is 1 over square root of 26. And don't worry about rationalizing. You can leave that as a standalone answer. Just like right above, we can leave that as a standalone. You don't have to rationalize. Tangent of half angle, that can be solved using our first two answers. Okay, sine was 5 over square root of 26. Cosine of half angle was 1 over square root of 26. Complex fraction, so we have top times the bottom flipped. Those cancel, and we get a nice clean answer of 5.